All right, guys, for those of you brave enough to do the 8.5 assignment to try to get a little bit of extra credit, thought I'd work through 3 of the problems with you here. So let's take a look at the first one right here, guys. We're supposed to find the measurement of AB. Let's pretend we don't know that it's 12. The first thing I would probably recognize is that line segment AB, which goes from here to here, is across from angle C. So I probably actually would have called this little c rather than line segment AB, and said, okay, that's what we're trying to find. So what is going on in this problem here, everybody, is that we have got a triangle that is not a right triangle. That's the important thing to realize. And if it's not a right triangle, basic trig, sine, cosine, or tangent, and the Pythagorean theorem don't work. What we're going to need instead is to use the law of sines, which is a proportional relationship, in order to figure some things out. Now, the interesting thing right here is that the only side length that we know here is that 14. That means that we're going to have to figure out the measure of angle A before we do anything else. So, to find the measure of angle A, we're going to start with 180 degrees and subtract the measures of the 2 angles that we already know. We know that angle B is 30 degrees, and we know that angle C is 59 degrees. So that's going to tell us now that angle A is, let's see what we've got here, guys, 180 minus 39 and minus 50. Let me double check that that was right. No, 30 and 59, excuse me. Oh, I got that wrong. Let's fix that, although the answer would have been the same. 30 minus a 59. Okay, so this angle here is 91 degrees. Oops. So angle A is 91 degrees. Let me go ahead and write that in here. And the reason I'm making a big deal out of that, everybody, is we said that you've got to try to find your peanut before you do anything else. The peanut is what I mean when you have one angle measure and the measure of its opposite side looking something like that. So we've got the 91 and the 14 right there. That's our peanut, and that is how we are going to begin our law of sines equation. So we're going to write the sine of that angle we know, which is 91 degrees, divided by the length of its opposite side, which is 14. Now over here on the other ratio, we could do the sine of angle B over little b, but we're interested in knowing the length of side C. So we're going to do the sine of angle C, which is 59 degrees, divided by the length of its opposite side, which is little c. And there's our proportion. Now from here we cross multiply. The c gets multiplied by the sine of 91 degrees, and that equals 14 times the sine of 59 degrees. And our variable is right here, c. It's being multiplied by the sine of 91, so we're going to divide both sides by the sine of 91 degrees. And that is going to isolate our variable and get us our answer. So those sine 91s cancel out, and we're going to get little c equals, and here we go. 14 sine of 59 goes up on top. So 14 sine of 59, close that off. And then down on the bottom, we're dividing all of that by the sine of 91 degrees. And let's hit enter there, and we end up with a 12.002. Now, the directions on this worksheet, if I'm not mistaken, said to round to the nearest tenth. That one's going to end up being 12.0 right on the nose right there. Even though it's 0.0, we still want to go ahead and put the decimal and the 0 there to indicate that we rounded. Actually, as I look at their answer right here, they have just plain old 12, but we always want to round if we can. So that is the measure of little c. Okay, that's how number 1 worked. Let's jump to number 4, which I think was the first one where they asked you now to find the measure of an angle. So we're looking for the measure of angle C right over here. And again, this is a non-right triangle. This one is obtuse, so we're going to be using the law of sines in order to solve for this one. And the first thing we want to notice here, guys, again, pretend that 18 degrees isn't there. We're not supposed to know that. is we've got to find our peanut before we go any further. We need to find both one side that we know and the opposite angle whose measurement is known as well. And this is kind of a weird one to see because of the way that this figure is drawn. But we know this 22 right here, and we also know the measure of angle A right there is 131 degrees. So it's drawn strange because it's a skinny, obtuse triangle, but that's what we're going to begin with. The sine, my dog is very, very excited about this problem, you guys. We're going to take the sine of angle A, which is 131 degrees, and divide that by the length of its opposite side, which is 22. Then we follow that up now by setting that equal to the sine of, well, we're interested in knowing the measure of angle C, so it's the sine of angle C divided by the length of its opposite side. All the way across this figure, that's the 9 right over there. So that is what the setup here for the law of sines looks like when we're trying to find a missing angle. So let's go ahead and cross multiply. We're going to get a 22 multiplied by the sine of angle C, and that is equal to 9 times the sine of 131 degrees. Okay, from here, we're trying to get C by itself, so eventually we're going to have to get rid of this sine. But first, we got to get rid of the 22. The 22 is being multiplied, so we're going to divide both sides by 22, and that will cancel with that. Now, if we were in class right now, I would probably tell you guys not to go ahead and do what I'm about to do next, but I think this is going to be easier for us to understand here this way. We're going to dump that into the calculator all at once and write it down on the next line. So we need to do 9 sine of 131 divided by 22. So let's see what that looks like. 9 sine of 131 degrees divided by, was it 22? 9 sine, yep, that's it. 131 divided by 22 is going to get us this weird decimal of, I'm going to write 0.309. All right, leave some space here, 0.309. Now, as I said in the video on the notes, it doesn't really matter what you write down as a decimal and how accurate it is, because we're never going to type that number in again. Let me show you what I mean. We need to undo this sign now to get C by itself. So the way we do that is with an inverse sign on both sides of the equation. Now on the left side, easy to see, the inverse sign and the sine cancel each other out, leaving us with a C equals. And on the right side, we're going to do the inverse sign of that goofy decimal that we just came up with. But what I am not going to do, let me go ahead and put an inverse sign, what I am not going to do is manually type in a rounded decimal. That number up above I'm going to get by hitting my last answer key, which on my calculator is right below the 3 here. On your TI calculators, it's usually second and then the negative key. It should say ANS right above that. And what that does is it automatically copies and pastes the last ugly decimal as long as it is and gets us a more accurate answer of 17.98. Everybody. Now again, depending on where they ask you to round, you'd want to follow those directions here. I think that this one, what did it say here, guys? I think it said to round to the nearest whole number, so I think that's going to get us 18 degrees now for the measure of C. And sure enough, that's the answer they had inside the figure there of 18 degrees. Okay, so that's messy. Let me get rid of all that junk that I put in there, but yeah, that's how number 4 works. Okay, and let's jump to number 7 where the directions are a little bit different. Solve each triangle. So what it means to solve a triangle is to come up with every missing piece of information that wasn't initially provided for you. So again, ignore the 3 red numbers. Those are the answers we're going to be coming up with in just a second. What we've got to do is figure out the 3 things that are missing. Let's look at angles first. We already know the measure of angle B is 38 degrees, and the measure of angle C is 50 degrees, so we've got to come up with the measure of angle A. That'll be the first thing we do. Now we know that this 8 right over here on the side is across from angle B, so that's what we would call little b. But this side up here across from angle A is going to be little a, and since this is angle C, this side down here is going to be little c. So we've got to come up with the measures of little a and the measure of little c. So those are the 3 things we need to know in order to finish this problem. Okay, we're going to start off with angles, which is the easiest thing to do here because we already know the measures of two of our angles. So if we wanted to come up with the measure of angle A, let me switch that over there. Okay, so the measure of angle A, we would take the sum of 180 minus the two angles we already know. Angle B is 38 degrees and angle C is 50 degrees. So that's going to get us A equals, and I'll do this with you guys. Let's clear everything out that we had here. 180 minus, forgot already, a 38 degree angle and minus a 50 degree angle. And that gets us 92 degrees now for the measure of angle A. So we'll write that here, and I'll also write that up here so we know where everything is at. Okay, now from there, because this is a non-right triangle and we're trying to find side lengths, that tells us that we're going to have to use the law of sines. And before we go any further, let's look for the peanut. Try to find a spot where you know both the measure of one side and the measure of its opposite angle. Well, that doesn't work with A because we don't know the measure of little a. It doesn't work with C because we don't know little c. The one side we know is B, and sure enough, we know the measure of its opposite side right there. So that's the peanut that we were looking for, everybody. It's the sine of 38 degrees divided by its opposite side length, which is 8. And that is going to equal the sine of, and we really could do either angle that we wanted to now, either A or C, because we know both of them. I'm going to go with A. So the measure of angle A we found was 92 degrees, and the side opposite from that is little a. There's your proportion. Let's cross multiply now. Little a gets multiplied by the sine of 38 degrees, and that product is equal to 8 multiplied by the sine of 92 degrees. And to get a by itself, we're just going to divide both sides by the sine of 38 degrees. Okay, those two cancel, and we're going to get a is equal to, all right, and a tough one to put in the calculator, but let's go for it. 8 sine of 92 up on top, 8 sine of 92, close it, and then on the bottom, divided by the sine of 38, yep, that's what it was, gets us an answer here of 12.986. Now again, looking at their answer, you can tell here that they rounded everything to the nearest whole number here, so that number is going to round to 13, although normally I'd prefer that as a rounded decimal. So little a has a length of 13. Now, one thing to notice right now, guys, angle A right here at 92 degrees is obtuse, and a triangle can never have more than one obtuse angle. The other two have to be acute. So that tells me already that angle A must be, we know this for a fact, the biggest angle in the triangle. That means that little a across from it has to be the longest side. So I knew that little a had to be longer than the 8 that we had there for B, and I think our answer seems to make some sense there. Now furthermore, as we keep going, angle B, this 38 degree angle, is the smallest angle in the triangle. So that 8 has to be the shortest side. So if 8's the shortest and 13's the longest, we know that little c right here has to end up being in the middle, somewhere in between 8 and 13. So let's get working on that. Okay, I'm going to try to clear out all of the work that we did right here. Let's try to move that down and out of the way. Let me switch colors on you guys to take you to blue here to help us keep things straight. And let's get working on this one. Once again, we're going to need the law of sines a second time. So we're going to use the peanut first. Once again, the sine of 38 degrees divided by its opposite side, which is 8. But now we're focusing on little c. So I need the sine of angle C, which is 50 degrees, divided by its opposite side, which is little c. Let's cross multiply. Little c gets multiplied by the sine of 38 degrees, which equals 8 multiplied by the sine of 50 degrees. Okay, here's c all by itself. We're going to divide both sides by the sine of 38 degrees. And what happens? Those two terms cancel, and we're going to get little c by itself equals, all right, 8 sine of 50 goes up on top here, 8 sine of 50, got it, divided by, there we go, the sine of 38 gets us an answer of 9.95. And again, their directions said to round to the nearest whole number, so that's going to come out to be 10 for the measure of little c. And we said a moment ago that little c should end up being in between the other two sides, longer than the 8 for side B, but shorter than the 13 for side A. And sure enough, that's how it worked out. Okay, so that's 3 out of the 8 problems on that extra credit worksheet worked out for you. So why don't you give the other 5 a try, see how you do, and let me know if you have any questions.